Hey guys, happy Saturday. Just got off work, so still got the scrubs. Hopefully not too COVID-y, but hope you're all doing well, staying safe, looking forward to Thanksgiving. But today we're going to talk about some nuclear fusion and fission. I was looking forward to this lab, hoping we were going to get to make some cool explosive devices, but because that probably wouldn't be appropriate, and some of that information is still classified, so kind of hard to get a hold of. But so we're just going to go over the brief overview. So there are two types of nuclear bombs, really. They're either going to use fission or fusion. Fusion would be like when a hydrogen bomb, so you're slamming together two hydrogen atoms to make that helium atom, making them combine. It takes a huge amount of pressure, huge amount of temperature. It's what powers the sun. It does create more energy than fission, but it's harder to sustain because of the huge amounts of pressure and temperature that it needs to sustain that. So it's not something that's really as widely used as fission reactions. So usually for these fission reactions, they're going to be using uranium. Uranium would normally occur as uranium-238. It's pretty stable. And then uranium-235 is what would be used for these fission reactions. It's very much not stable. It's not happy. Got a lot of energy going on there. So what happens in these reactions is that atom is going to be hit with another neutron. It's going to briefly become uranium-236, which is incredibly unhappy and excitable, and that's going to cause that uranium-236 to release a bunch more neutrons. They in turn are going to hit more uranium-238s and cause that same reaction to continue on and on, and that's what causes that chain reaction. Unless that would be contained, it would continue on until there were no more atoms for those to bump into. So in order for like these big power plants, these big nuclear power plants, they have acres and acres of equipment to contain these reactions and to still produce the power that they need, but not cause an explosion, because we don't want that. So it can take up to like 4,000 stages in these big diffusers. They can also use huge centrifuges to kind of split these, because they want to isolate kind of that uranium-235, and really the only difference between it and the uranium-238 is there's a teeny tiny, like 2% weight difference, and so they use the centrifuges or diffusion to kind of split those out so they can contain those U-235s and use those to create power. Or a bomb, I guess, if that's what you wanted to do. So that is a brief overview. It's very in-depth. I'm sure I could find hours and hours of information on this, and I'm just briefly hitting the surface because I am not a nuclear chemist, and it's a whole lot of information. It's super interesting, but it's a lot. So anyways, I hope you guys have a wonderful weekend, and once again, happy Thanksgiving. See you guys next week.